We will be talking about gases in this chapter, and we're going to start with the basics of gases. And specifically, we're going to focus on the properties and what we will be using in our gas calculation, and starting with gases and gas pressure. So, we talked very early in the semester about different states of matter. We have our solids, we have our liquids, and specifically gases, they have the most freedom of movement due to the nature of the gas particles being apart and move at a higher speed, or we can say they have higher kinetic energy compared to particles in solid or the gas phase. And just this is a refresher over what properties of gases, they of course can expand freely to attain the shape and volume and container. Unlike solids and liquids, they are compressible. And of course, they will mix freely with the other gases. So you might know or not that there are gas solutions, right? Like air is a popular example of gas solution. It's mixture of nitrogen, oxygen, carbon dioxide, and other gases. And to describe the properties of gases, we will be looking at four quantities, which are pressure, volume, temperature, and then moles of gas. And you will see later that we will be using these specific quantities in gas laws and in gas stoichiometry. Now, with pressure of the gas, we've discussed just the previous slide that gas particles are moving fast. They're moving randomly, as you can see in this illustration. This is, of course, an exaggerated picture of gas particles, and the gas particles are bumping into each other, bumping into the walls of this hypothetical cube. And because of this property, they tend to exert a force when they collide with the surface or other gaseous particle. And this here leads to pressure, which is the force exerted per unit area by gas molecules when they strike the surfaces around them. And this is very basic. Physics is pressure equals to force over area. And as a result of this constant movement, the gas pressure is going to occur. And this is why, as I described in the previous slide, because of the property, we are going to use the pressure property in our calculations and in gas laws. Another thing related that we need to know are the units of pressure, because if you're taking 1312, or if you're taking 1412, you will see these different units utilized at the beginning of the semester. And the most popular one that you might have heard in lab about, or you might have heard just in general about, is millimeters mercury or inch mercury. And these are used in instruments that measure the pressure of gases, such as barometers and manometers. But the SI unit of pressure is Pascal. The modern common unit also that we will be using in some of our calculation is atmosphere, or ATM. And this is just a list of conversions that we will be using in our calculations at very basic conversions between the units of gas. By the way, there's no need to memorize them. These all will be given on the formula sheet. Now, the last thing I want to talk about before we do a couple of examples with calculations is devices used to measure pressure. And we're going to mainly focus on barometer. I'm not going to talk about manometers. Please feel free to read about them over the internet. But this is a very popular device to measure atmospheric pressure. And the idea behind it is if you have a container like this container right here, and it's filled with mercury, and you dip a glass tube in it. Now, note that this glass tube is open-ended, right? And in this case, the mercury will not rise because the atmospheric pressure exerts pressure on the actual mercury and also inside this glass tube. If you close that barometer, the side, like one end of that barometer or the glass tube, the atmospheric pressure will have only access to the exposed part, and as a result of that pressure, it will push. Of course, depending on the pressure, the atmospheric pressure will tend to have fluctuation, very minimal fluctuations, I would say. But due to this pressure, the level of the mercury will rise in the tube, and you can measure the height of that liquid displaced. And just as a reminder, this is something you're going to again use in Gen Chem 2, is 1 atmosphere equals to 760. No, again, need to memorize everything is your formula sheet, but it's worth mentioning. And let's look at simple conversions on how to convert from one unit to the other. And again, this is basic dimensional analysis. No need to stress about it or put in too much work into it. And starting with how to convert from bars to millimeters mercury. And I'm going to start with the 0.776 bar right here. And note, if when we, let's go back to the slides and look, note that there is conversions are mostly to atmosphere. Okay, so in this case, you can guess, except for, yeah, it's all conversions to atmosphere. And in this case, what I would do is I would convert first to atmosphere and then convert to millimeters mercury. So I'm going to say 0.776 bars. And I'm going to say that in 1 atmosphere, there is 1.01325 bar. And then I will switch from atmosphere to millimeters mercury, which gives me 582.04786578. And of course, this is infinite sig figs, and then 3. So it becomes 3 sig figs. Therefore, it becomes 582 millimeters mercury. On the second problem right here, I want to convert from 225 kilopascals to torr. And I'm going to start the same thing again with 225 kilopascals. And then I'm going to convert to atmosphere. So in 1 atmosphere, there is 101.325 kilopascals. And in this case, I'm going to convert now to torr. Okay, 760 torr in 1 atmosphere, and this gives me 168.6387861. And let's look at the sig figs. This is 3 sig figs. Here is infinite. Here is infinite. So in this case, let's round this up to 1690 torr. It is worthy to mention that 1 millimeters mercury equals to 1 torr. Something, if you want to know about or make your life easier when you're converting. Now, let's look at a problem that you can do that's very similar. So you're given the following pressures right here, and you are asked to convert, to identify the greatest pressure. And note here that the pressures are different in each case. So in this case, what I would do is I would convert everything to atmosphere to only 1 unit, which is the easiest because on the conversions that I showed you, they're all converted to atmosphere, and then I would just pick the one that is the greatest. So I will start with the first one. I can say 1 atm over 760 millimeters mercury equals 2.9684210.526 atm, and then 1 atmosphere over 1.01325 bars equals to 0.765852445 atmosphere. And then for C, we have here 1 atmosphere and 760 torr, which equal to 1.173684211 atmospheres. And then finally, I have 1 atm over 101.325. And this gives me 2.2205775 atmospheres. So comparing all of these right here, it seems the answer is D, which is the greatest pressure. And I hope this makes sense, and I'll see you in the next video.